3.4 equations and graphs of polynomial functions. So the last thing we're going to do here is solve, look at graphs, and then we're going to look at the different polynomial graphs as our very first lesson as well. So from the very first lesson as well, I meant. So multiplicity of a zero. A zero is just another word for x-intercept or root, correct? Root, x-intercept, zeros are interchangeable. They all just mean x-intercepts. So the multiplicity is the number of times a zero of a polynomial function occurs. The multiplicity of a zero of a root can be referred to as the order of the zero or the root. So these all just pass straight through. If they pass straight through, they all have multiplicities of 1. Means there's only one x-intercept at each of those. And you don't have to say multiplicities of 1. If it doesn't say it has a multiplicity, you assume it has a multiplicity of 1. Okay? But other multiplicities, you have to. This is a point of tangency. So this one here has a multiplicity of 1, but this one here has an actual multiplicity of 2. Because what happens is, it comes up, it hits the one x-intercept, and it hits the other one, and then it bounces it back up. So when you have this bounce, that's 2. Hits one, hits the other, bounces it back up. This is called the point of tangency. Now, so for simplicity's sake, we'll say it has a zero of multiplicity 2. But a zero of any even multiplicity could be that one. So it could be 2, it could have 4 x-intercepts there, it could have 6, it could have 8, it could have any more. Okay? So what they'll often say on the diplomas, they'll ask for the least multiplicity or the lowest multiplicity, therefore making it be 2, right? If not, then you could give infinite number of answers, right? Now, why would a 4 do that? Well, if it was a 4, it would just end up being a little longer on the tangency. It would just bounce, 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 bounce up. So you bounce on all 4 of them. Bounce up, bounce up, bounce up, bounce up. Shoot. Okay? So even multiplicities give you that point of tangency. This is a multiplicity of 3, different than a multiplicity of 1. Multiplicity of 1 just goes straight through, correct? Multiplicity of 3 makes this S shape, because what it does is it bounces, it comes up, it bounces once, tries to send it back down by bouncing twice, but then it bounces a third time and sends it up. So you get this like little S curve through it. If you have this little S curve, it's a multiplicity of 3, or it could be 5, or 7, or 9. The only odd it can't be is 1, because 1 goes straight through. So that's why they'll ask for the least degree, so that they force it to be a 3. Okay? But it could be a 5 or a 6 or a 5 or a 7. 6 would not be true. That's a total lie. Okay, this is called the point of inflection. Now, something to note about the leading coefficient of a function. The leading coefficient of a function, the sign of it is how it ends on the right-hand side. So this one here would actually have a positive leading coefficient. Because it ends positive on the right. What does that mean? That means the number, the coefficient in front of the largest exponent would be positive. That's what the leading coefficient is. The leading coefficient is the one that leads the equation. This one would have a positive leading coefficient. This one would have a positive leading coefficient. Okay? So it depends on our right arm, whether it's a positive leading coefficient or a negative. If you guys can't see over here, you can come into the abyss of this space right here. You can move your, make another row. There's so much room here. Like even this one has lots of room. I'm still recording and I forgot I am. See that? You could do salsa. You could do a cartwheel. Handstand, maybe cartwheel. I would kick a whole bunch of faces, but a handstand. If I could do a handstand? Yeah. I could. I don't really want to. All of a sudden I come down and kick someone in the face. Yeah, then I lose my job. Yep, they're recording. Okay, good times. All right, so For each of the graph of the polynomial functions, determine the least possible degree. Okay, so this is to note. Degree 1 functions are what? We did these in grade 10 and 9. What are they? Good old line. So y equals mx plus b, right? Degree 1. Degree 2, we did in grade 11. What were they? Yeah, quadratics. So y equals ax squared plus bx plus c. What would my leading coefficient be of this one? Negative. Degree 3 graphs make a weird S shape. Okay. Degree 4 graphs make a W or an M. I used to have the last name Wagner. It was wonderful. Look at positive. This is a positive graph because it makes the word Wagner. And then it's a negative quadratic or a quartic graph because it makes the word math. Except I don't agree with that statement, but whatever. You can remember it that way. So this is a degree 4. And then a degree 5 is just like a crazy S. Or it's like the kid didn't want to quit writing the S, or you guys doing brackets on a set statement. Basically what that is. That'd be a degree 5. So that's kind of what they look like. The catch too is you can only have as many factors or x-intercepts as what? What did I tell you? You can only have the maximum number of x-intercepts or factors is equal to the what? Yeah. So on the degree of the graph. So remember we did x to the 4s yesterday and x to the 5s yesterday, and those would get you, an x to the 5 would get you at maximum 5 factors, and x to the 4 would get you at maximum 4 factors, and you could turn those factors into roots. Remember we said that? So the maximum number of x-intercepts is equal to the degree. That's the maximum number, right? So we want to know the least possible degree. Looking at these, this is degree 1, arrows in opposite directions. Degree 3, arrows in opposite directions. Degree 5, arrows in opposite directions. We agree? So odd degree functions have what? Arrows in opposite directions. What about even degree functions? These ones. Where are my arrows? Same direction. So at the very least, you can minimize the degree of the function based on where the arrows are going, right? Okay. So this one is arrows in both directions. We agree? Why would I say least possible degree? Because remember, like a point of tangency could have 2 x-intercepts or 4 or 6 or 8 or onward, right? This one goes through how many times? 1. This one is or 4 or 6 or 8 or 10 or 12. But they told me what? Least possible degree, correct? So how many x-intercepts are here? 1 here, and so how many is that maximum? 3. 1 and 2 is 3. Grade 1 coming back at you. 1 apple plus 2 apples is 3 apples. Yep. We have arrows in opposite directions, so it's either 3 or 5 or 7 or 9 or etc. Right? Or 1, but it's not 1 because it's not a straight line. So the least possible degree this one could be is what? 3. Okay? Now we're going to go to this one. We'll just do the degree of it. So, arrows in the same direction. It has to be degree 2 or degree 4 or degree 6 or degree 8 or degree 10, right? Arrows in the same direction. Okay? How many x-intercepts does this one have? The negative 4. How many times does it cross? 1. How many times does it go through the 3 here? 3. So 1 plus 3 is? So what's the least possible degree? Could the entire function be completely above the x-axis in this case? A degree 4? A degree 4 could be completely above the x-axis and have no x-intercepts. So you also have to base it off your max and mins as well. Right? This one It's a really weird way of writing Wagner, but you can write it. So, degree 4. Okay? You have to look at what it looks like. So if it makes like a W shape, the least possible degree it could be is 4. So you can check the x-intercepts, but if there aren't any, you have to go based on what your graphs look like. Sorry. Okay. Okay. The sign of the leading coefficient. A, what's the sign of the leading coefficient on A? Negative or positive? Why? So that right arm is down, so it has a negative leading coefficient. The leading coefficient is the number that's in front of the largest exponent. So in front of the x cubed exponent, I have a negative number. That's what that says. What's the leading coefficient on B? So in front of my x4 exponent, I'm going to have a positive. Bless you. Okay, the next one says the x-intercepts and the factors of the function with least possible degree. So what would my x-intercepts be here? X equals what for this first one? Negative 4 and? Okay, what would my factors be then? X plus 4, x minus 1 squared. Why? Because there's 2. What's the x-intercepts on this one? X equals negative 4 and 3. What's my factors? X minus 3 what? Cubed. Then it wants the intervals of the function that are positive and negative. So basically where the graph is above the x-axis, where the graph is below. So for A, the graph is above the x-axis here. We agree? Is that the only place it's above? So it's positive from negative infinity, we're listing the x values, right? To what? Nope, negative 4. Round bracket. And the reason why I put the round bracket instead of the square bracket is negative 4 is actually on the x-axis, is it not? You treat the x-axis like it's ground level. Okay? So if it's on the ground, is it positive or negative? Are you above the ground or below the ground when you're on the ground? You're just on the ground. So when you're on the ground, these here aren't included in the positive and negatives. They're open dots. Okay? So the graph is only positive on the left of negative 4. On the left means not equal to. Okay? It's negative from negative 4 to 1, and then 1 to infinity. Is it actually negative at that dot? No. So we have to list 2 intervals. We can't just say greater than negative 4, because it's not here. So the negative, you would state from negative 4 to 1, or, which is the union symbol, 1 to infinity. So these are always going to be round, not square at all. This graph is positive here and here. So it's positive from negative infinity to negative 4, or what? 3 to infinity. It's negative all the way down here. So it's negative from negative 4 to 3. Okay? So here we need to sketch these by not putting them in your calculator. A is the easiest one. Why? What form is it in? It's in factored form. Factored form helps us get what really quickly? X-intercept. So this one, from this equation, I know I could rewrite it as this. Okay? So I actually have x-intercepts at what? X equals multiplicity and x equals. I know I have a leading coefficient that is negative. So I know my arrow is down on the right. Is this function an odd degree or an even degree? How do you know? Nope. That could help us, but how do we know it's even and what degree it is? You take your x values and multiply them. So if I FOILed this out, you could FOIL the whole thing out and look at it, or you could just take the x's and multiply them. X times x times x times x is x to the 4. So I know this is a what function? The last thing I want to pull off here is my y-intercept. Okay? My y-intercept is always the constant. It's the number at the back that doesn't have a variable. So if I can get the number at the front, the leading, by just going all the numbers at the beginning multiplied together, correct? So if I went negative 1 times x times x times x times x, this is actually a leading coefficient of negative 1, x to the 4. That's actually my first term. My back term and first term are really easy to find because when you do your back term and your first term, you don't really have to collect a whole lot of things. Okay, so the first term I can find by multiplying all the front things together. The back term, which is the constant, the term without a variable, I can multiply all of the back numbers together with including the negative 1. So if I go negative 1 times 1 times 1 times 1 times negative 3, I actually get the y-intercept. So what's negative 1 times 1 times 1 times 1 times negative 3? I have a y-intercept of 0 and 3. So let's plot what we do know. So we know we have negative 1 as an x-intercept. There's 3 through there, so we're going to have this little s point of inflection going through, right? That little s shape. And we know we have 1 going through 3. We know we have a y-intercept of 3. If I wanted to sketch this more accurately, what would I need to find on my graphing calculator? My max and my min, would I not? Okay, bear with me. Don't draw it this way because I'm going to show you how bad of a sketch this is going to be because it's a sketch because I don't have the max and mins. But I know that it ends down, right, on both ends. Why does it end down on both ends? Because x to the 4 graphs have arrows in the same direction. So I know it ends down on both. I know this one goes directly through. Why does this one go directly through? It's a multiplicity of 1. There's only one x-intercept, right? So I know I have probably a maximum up here. Cuts down through this y-intercept. And what kind of shape do I have through here? Like an S shape, right? Right? Because it's a point of inflection. So it's going to come through. It's going to do an S shape through it. And then it's going to go down. I have arrows in the same direction, which means the leading coefficient is down. Degree 3, degree 1, went through my y-intercept. The only thing that's probably off is my maximum. Why? Because I didn't find it. I have no idea. It could be really high, it could be low, it could be anywhere, right? How could I accurately get it? Second trace max. Once you put it into y equals, left bound, right bound, get it. Okay? All right. So you have to, I always start on the far right because I know where my arrow is going and work my way back. Okay? Why is B so much harder or C so much harder? We're going to do C, by the way, but why are they so much harder? You have to do synthetic division to get your roots, your factors first. Okay? So we have negative 2x cubed plus 3x squared plus 11x minus 6. Negative 2x cubed, what was it? Anyone have it printed? Plus 3x squared. Okay, we need to get the factors and go. Try it out. Then get the x-intercepts as well. Anyone? Someone? Want to give me info? Oh, that's... Okay. So we know we have a factor of x. Oops. Minus 3. So we have negative 2. Can we count down? 3, 2, 1, 0. Yes. Negative 2, 3, 11, negative 6. Drop the negative 2. 3 times negative 2 is negative 6. Add them. Negative 3. Multiply them. Negative 9. Add them. Positive 2. Multiply. Positive 6. Happiness has ensued. You got a 0. Okay. Negative 2x squared minus 3x plus 2 because we took an x out, right? We're down 1. Now we're going to have to do what? Decomp. So what times what equals negative 4? What plus what equals negative 3? What multiplies give you the outside, adds give you the inside. Yeah. I appreciate how you really, I got it. It was perfectly sent in the correct direction. The angle of elevation was also correct. So negative 2x squared stays. The only thing we're replacing is the negative 3x with negative 4x minus 1. X, and then add the 2 at the back. Group, plus sign in between. Take out a negative 2 and you're left negative 2x, and you're left with x plus something is wrong. What did I do? Positive 1. Boom, there we go. X plus 2. Take out a plus 1 and you're left with x plus 2. So our factors are negative 2x plus 1 and x plus 2, and the infamous one that we always forget about, x minus 3 at the top. We can't forget about that one. Often when I get x minus 3 at the very bottom of the question, before I even like do anything else, I just write it, so I don't forget to write it at the end. Yeah. Oh, because this is one term, this is another term. I GCF the x plus 2 out, so I only have 1, and then I'm left with that. Yeah. So all of these are multiplicity 1. So we have, bless you, negative 2x plus 1 equals 0. She's allergic to me. That's what it is. X plus 2 equals 0. Next class will be better. I apologize. X minus 3 equals 0. Negative 2x equals negative 1. Divide by negative 2. X equals a half. Subtract the 2. These ones are easy. X equals negative 2. Add the 3. X equals 3. Okay, so I have x-intercepts. Yay. What else helps me draw? The leading coefficient. Thanks, guys. So helpful. It's all of you at once. Okay, the leading coefficient is negative, so my arm is going to be attached to the pen still. The arm of the graph is going to be, no, that was funny. The arm of the graph is going to be down on the right. And what's it going to be on the left? Up, why? Because the graph things are like that. Good explanation. Because it's an odd degree, it's a degree 3, it makes the S shape. Odd degrees always have arms in opposite directions. Yes? Okay. Y-intercept, super easy. The only thing, okay, the graph, the equation last time was super easy because it gave us the x-intercepts instantly, correct? This style of equation, when it doesn't give you the x-intercepts right away, when it's the actual standard equation, gives you two things really quickly. It does not give you your x-intercepts. That does suck. But it does give you two great things still. It gives you the leading coefficient, which the other one still does, but whatever. I'm not beggars, heavy choosers. But what it does do that the other one doesn't give you quickly is the y-intercept, because here's the constant. So that's my y-intercept. So I have a y-intercept of 0 and -6. So if I go to sketch this, I don't want to go back. Okay, I have an x-intercept at 1/2. I have an x-intercept at -2. I have an x-intercept at 3. All of these x-intercepts I'm going to go straight through, right? Why am I going straight through them? Because they're not squared or cubed. There's just one of them. So boom, straight through. I have a y-intercept at -6. This says sketch. It doesn't say accurately perfection draw. If it does, if it's on your graph, if it's a graph on your test, sorry, make sure you find the appropriate maxes and mins so that it's drawn properly. I'm just sketching here. That's all I expect of your textbook. But I know it's going straight through here, and I know I have an arrow going down at the very minimum, right? Because the leading coefficient is down. I know this one's going straight through here, and I have an arrow going up because they need to be in opposite directions. We agree to that. Yeah? We need to go through this y-intercept, so I'm going to. Now, some people do this. I'm going to wreck my graph. Oh, that's going to be sad. I'm just going to show you without wrecking my graph. Some people like connect dots. So they go straight to the y-intercept. Does a graph smoothly go like this straight to the y-intercept and then they make the y-intercept be a minimum? Is your y-intercept a minimum or maximum most of the time? No, it's a number that it probably goes through. So if you look, is the y-intercept closer to this x-intercept or the 1/2 x-intercept? The -2 or the 1/2? Which one is it closer to? The 1/2. So I'm probably actually going to come back up through the y-intercept. I'm not going to go down, cut through it, and then just like do this really tiny curve back up. That just is weird. So I'm probably going to come down here, get a minimum somewhere, and then come cut back up through it. Now, are my maximums and minimums completely accurate because I just drew something randomly and think they're accurate? No, they're really horrible probably, or they're relatively similar. But if you cut through the y-intercept here and then tried to squeeze back up, yours is really bad. Okay? Mine is kind of bad, yours is really bad. So make accurate thoughts on your drawings. Okay? So I'm going to give you, we're not finishing the lesson completely, but I'm going to give you questions on what we did do. And then we're going to finish it up on Monday and Tuesday, but your test will be on Thursday. Remember, after this test, you have a cumulative. So the cumulative doesn't follow immediately after the test. The cumulative follows a week after. So Thursday, you're going to have this unit test, and then the next following Thursday, you're going to have your cumulative. So we don't have tons of class time to review for cumulative. So why do I give you a week expansion? So that you can review for cumulatives on the side. Okay? We don't have enough days for me to spend 5 days to review on each cumulative. It's not going to happen. I know if we were all dreamers and this was a dream world, that would be great, except it's not. It's a world of 11 units in 16 weeks. So we just don't have that chance. Okay? So you're going to have to do some review on your own. Plus in university, they review nothing for you. If you get a package that actually has questions, you're yay, good for you. If not, you're just doing it on your own. Okay? So, you've got to learn to review on your own. So, your homework is on page 149. Number 4.